hello, welcome to the show. It's me, JP, and it's time for JP's product pick of the week. So thank you so much for stopping by today. We have our chats. If you're wondering where to chat, go to YouTube chat or to our Discord. Where's our Discord? Well, that's over at adafruit.it/Discord, and you can look for the live broadcast chat channel, and that's where it's happening. Thanks Dave Odessa and Beata Graf Avdalhagen for joining us over in the YouTube chat. And hello DJ Devon3, Blitz City DIY, Jim Hendrickson, stopping in over on Discord. Hey Thin Man, hello. I'm doing well. Hope you also are doing well today. Thanks for asking. Let's see. What have we got here today? We've got Splat. What is this? What's this all about? I'll tell you. Hey, Rufus. Rufus just joined us over in the chat as well. Hello, Vid Carrix. Thanks for joining us in the YouTube chat. Hello, Some Nice. Give us a moment to get all caught up here. I'm going to have a sip of water. How about that? Okay. This is the product pick show. I pick a product. We take a look at it. We give you a humongous discount on it. This week it's 50% off, maximum of 10 per customer. We just took 100 and put them in stock. So this product was appeared out of stock until moments ago. Now it's up and running. And in fact, if you want to go check it out, you can head to that URL right there or over to that QR code. Hey, I did it right this week. I pointed in the right directions. This display of mine is mirrored, so it's all backwards. Head on over there. You can watch this show from inside of that product page right there. And you can get the discount just by throwing them in your cart and buying them before the end of the show. So unlike other discounts that we do, which tend to be a coupon code, you don't have to do anything like that. You just have to buy it before the end of the show or a little grace period afterward. And if it is still in stock, sometimes things sell quick. Sometimes we get by with the 100 or so that we put in. You will get it at the discounted price. Nothing to worry about. But then we reset it after the show back to full price. So before I say any more, let's jump back a little bit. This is a pretty new product, but just a week or two in time to have Lady Ada tell us all about it. Take it away, Lady Ada.
The TCRT1000 breakout board. And you can see, I'll show the sensor later. I'll actually go to this photo. Okay, so this one. On the end here is a right angle optical sensor, and there's like two little eyes, and they look so adorable. They're like little googly eyes. But really, one is an IR transmitter, and one is an IR photo transistor. What happens is that one half, the LED half, like beams out light, and then it bounces off some object and then will bounce back into the other eye, which gets detected, and then you know that there's something in front of the eye. It's basically an analog, proximity / distance / obstruction sensor. Not meant for big distances. It's like good up to like maybe 5 millimeters or so. But what's nice is that, especially the reason I got this is that if you're trying to measure something that's rotating and you have a reflective metal strip around it and then like a little black mark, like a Sharpie mark, it'll not reflect off that black mark, and so you'll know when it's spinning. So it's good for like detecting rotation as well as proximity. So on the animation, you can see in the bottom left there's a little red LED that says signal. So as you get closer, that'll get brighter and brighter because that's indicating that the amount of voltage that's getting generated from the reflected back light is higher, is lower. It goes down when something is nearby. So it's reverse polarity because it's a transistor. There's a potentiometer in the middle, so you can adjust the LED current. You can adjust it from 1 milliamp up to 100 milliamps, which is the max range. This is one of the few right angle optical reflective sensors. We have, some breadboardy ones, but you have to like connect the resistors and you have to wire it up. This is kind of all in one. It's ready to go. You can plug a JST PH 2 millimeter pitch cable in and just like you're ready to go. Or you can solder to the wires, to the pins on the board. Either way, this is a very easy way to get started with a photoreflective sensor.
Okay. Yes, indeed it is. Hey, look, that's it right there. This right Here is my product pick of the week this week. It is the TCRT1000 photoreflective sensor. So this is a stemma sensor, meaning we've got the little 3-pin stemma connector there, so you can plug that into your project with a variety of different cables that we have. We get power, ground, and signal over those lines, and that means you can use this essentially like it's a button or a switch. You can tell your code in Arduino or CircuitPython to watch for this. It's going to be high when it doesn't have anything in front of it, and then if something gets between about 4 to 1 millimeter away, which is adjustable with a little trim potentiometer there, it will trip the switch. So it's going to act like a digital thing. This is not like a distance sensor in an analog sense. But what it will tell you is, hey, something's there or something's not there. Now, as Lady Ada mentioned, one of the neat things about this is that it can be used for optical encoder strips. So you can make your own encoder strips to tell when something is either moving linearly or rotating. If you put essentially a disk of symbols with a regular interval, you can count those pulses and know when you're spinning, how fast you're spinning if you use this for an optical encoder on a wheel sort of thing. And so what I wanted to do is actually show you a little demo of it just in sort of basic action, and then also with a little DIY homemade optical disc, which some of you may recognize from a drum sequencer project I did a while ago using a similar type of sensor, but those had to be sort of built all onto a perma-proto board and wired with resistors. They've got mounting holes on them, we've got an easy connector, so these are going to make this type of project, I think, quite a bit easier. So before I jump into demos, let me head over to the product page for this. Oops, hold on one second, I broke a thing. I'm going to fix a thing. And let's bring my Chrome window. There you are. That one right there. So that's the URL. It's product 5913. If you head there right now, you can see we have a bunch of them in stock, down to 89 of them in stock. So you can throw those in your cart and you're gonna get them for this discount price, half off, $2.48. Really nice, inexpensive way to be able to use this sensor with minimal setup, very little setup required. And if you scroll down a little bit, you'll see we've got this show right there. You can watch the show inside of the product page. Maybe some of you are. And if you keep scrolling down, you'll see we've got the Learn Guide here by Liz. So if I take a look at that link on the pinouts page, I always like to check this out. You'll see we have broken out both on the stemma cable and on 3 pins there. If you do want to breadboard this or solder some pins on to put it into a perma-proto board or other circuit board. And this will let you know we've got the power on there can be, I think, anywhere from 3 to 5 volt, if I'm not mistaken. We mentioned 5 volts here, but I think you can run that with 3. And then we've got ground and signal. That's the output signal. And so this is going to send the high message, the high value, most of the time until you cover up that, get close enough to that sensor, then it drops down to 0 volt. And so that's how we'll read that low signal on our code. And this also mentions there's the tiny little potentiometer there. You'll just use a little flathead screwdriver, and that lets you adjust the sensitivity of the distance that it'll notice the object and trip at. You've also got a power LED that'll show you, it'll light green when there's power to the board. And then there's a red LED which will go red as the photo interrupt or reflector notices the object. And then we've got setup here for using it with CircuitPython and Arduino, but it really just acts like a digital switch. So any type of digital button on a digital input pin is how you'll be able to use this. So what I'll do is jump to my overhead cam here. And so you can see what I've got going on here. This is our TCRT1000 optical reflective sensor. I've mounted it on some little 2.5 millimeter nylon standoffs onto our little swirly grid board there. And there you can see I've got the 3-pin JST cable running to, in this case, a Pi Portal. Just plugged right in there. This has the same connector on it, makes it nice and easy. And when I get close enough to the sensor, you'll see it trips. You'll notice the little red LED here go brighter when I get close to it. And I'm also just telling it in code to switch the color of that box from green to red. Now, the little disc that I made, this is just a printout, and I think, yeah, in some cases I've used some sort of like chalk marker to add little dots here that were used for the drum sequencer. But you can see if I get this, let me get this aligned, this should show it pretty well. So as I am pointed at the black versus white, and in this case, actually, my black ink is, confusingly, the black ink is quite reflective from the toner, and the white paper is not as reflective, so this might look backwards. But I think with that chalk marker, it would be the opposite. So you can experiment with different materials and different paints. I actually have some of that sort of knockoff Vanta black, super black paint that's not reflective at all. I'm going to try using that, I think, for an upcoming project with this. But here you can see, as I spin my disc here, I'm able to detect the markings there, which is something you can use for robotics to have precise wheel positioning, know the rotation of a wheel. There are different patterns that you can use, or a pair of these to be able to tell direction as well. This setup that I have here wouldn't do much good with telling forward or backwards, but it does know when we are tripping that. And you can see it operates quickly. It's faster, I think, than my screen there can update very effectively, but it's, you can see the little LED blinking there too. So it knows when it's in front of one of the reflective bits or not. So that'll work with this sort of arrangement, but it'll also just work with anything. Here's a little battery as I move that closer. Boop. We're just tripping that. So you can use this, and we say the word interrupt. It can act like a photo interrupt. There's something got in the way of it, but it's really a optical reflective sensor, so it tells if we've reflected that infrared light back or not. And if you look here, I'm going to try to point this and focus. You can see the little purple light there. That's the infrared light. So that's the infrared that's getting bounced off of whatever and back at the next little eyeball there, which is the phototransistor, which can tell if it's seeing the infrared light or not. So that is the little IR light there in practice. It also means there's no visible light to it. And speaking of visible light, if you want to make this thing a little more stealth, you'll see on the back here, let me get a good zoom in here. On the back here we have some jumpers, and you can cut this jumper if you don't want the power light to light up, the little green light that you see there. And we can cut the little jumper here that says SIG for signal if you don't want to see that red LED there indicating the reflection coming back. So those are some options you have there. You can also see here we've got some little helpful info. Lets you know the distance, works somewhere between 1 and 4 millimeters. And then the potentiometer on there for the trimmer pot to adjust that distance goes from sets the IR LED to output anywhere from 10 milliamp or draw 10 milliamp to 100 milliamp. So that's the difference in strength of the IR LED basically is what changes its effective range. And then here you can see we've got our breakout pins for signal V in and ground, and then it also mentions on here this will run on a 3 to 5 volt signal. If you take a look back at the web page here, you'll see examples are of wiring and code for Python, both CircuitPython and Python with Blinka on something like a Raspberry Pi, as well as Arduino. And if you look at my example again, you'll see the code here. Key things I'm doing really are this from digital I/O. I'm importing digital in-out, direction, and pull. And then we're setting up, in this case, it's the board D4 pin. Let me refocus this. The board D4 pin is what I'm plugged into here with this JST cable. So that's just like any digital I/O pin. We're setting it up as a input with a pull-up resistor, and that means that it's pulled high until it gets interrupted, and then it's going to drop low. And then we're using a little state variable here to sort of debounce it. And then the main loop, we say if it's been tripped, so if the IR value essentially goes to false or 0, if the state is not true, this just prevents it from looping over and over and over again, so this holds it. We then change that state variable. We set the background color of that block there to red, refresh the display, and then you can also see how I'm updating the word tripped here. Let me refresh that so you can see the REPL. Oh, there we go. Boop, tripped, tripped, and tripped. So that's it. It's really easy to use. DGDevon3 says, if it's an IR sensor, can it be triggered by a TV remote or other IR transmitter accidentally? That's a good question. I bet it can. Let me see. I can grab a remote and try it right now. I think this one's got battery. Yep. So I have a remote over here, and if I point at that, let me try that again. I saw it trip. Did my batteries die on the remote? It really did work there. I saw it blink. Oh, there it goes. Yeah. So yeah, you can, as long as they're within the range that photo transistor is checking, the any spurious IR can trigger it, which means if you're using this in something like an optical encoder setting, you might just want to make sure you don't have a lot of light leakage. You can put a little electrical tape around it or something like that, or gaff tape. If you take a look at the downloads section of the Learn Guide here, you can head over to the data sheet, and I think this will tell you the wavelengths. So it's a 950 nanometer, which is a really common one for IR remotes. But I guess if you get outside of that far enough, then you don't have to worry about it. But maybe some outside filtering or light blocking will take care of it. And that's the little sensor there on its own. But of course, the difference here with this board is that we've got this nice breakout that makes it really easy to plug and play and use. So good question, DJDevon3. Thanks for that. Does anyone else have any other questions or thoughts? Let me know. If not, I think we'll wrap it up. There's a nice little set of photos of it there. You can see it's fairly compact. Got a little right angle there, so you can mount that on your enclosure. Rufus says, or on purpose, if it's responsive enough to be able to capture IR pulses for decoding. I don't know. I don't know if that's a good question. I think it would just depend on the reaction speed of that photo transistor there. I think we have better products for that are designed for decoding, but it could be a fun experiment. So if you pick up one of these, Rufus, and try that out, I'd love to know. Can you hack that into being a IR receiver? I'm not sure what other extra circuitry is on the boards that are designed for that. It's a really good question. All right, I think that may be it. Do I have anything else to show here? I think that'll do it. So there's the URL if you want to go check that out. Pick some up for half off right now. We have $2.48. Normally those are about $5, and we have 64 of them in stock, so we've still got a few. Mouse says, thanks for the stream. I've been wiring up a synth module prototype while watching. Excellent. Hopefully you'll bring that on show and tell. I'd love to see it. Yeah, DJDevon3 was thinking it could just make for a good basic IR trigger. Very cool. Lots of out-of-the-box thinking here on this. Love it. Okay, I think that will do it. So that is my product pick of the week this week. It is the TCRT1000 photo reflective sensor with stemma breakout. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. I will see you next time. Bye-bye.